Okay, let's dive right into this explainer and decode the hidden language of Cambridge physics examiners so we can absolutely master energy levels and line spectra. Welcome, everyone. I want you to think of me as your football strategist today, but instead of analyzing a pitch, we are dominating the Cambridge physics exam paper. We are looking at one of the most notoriously misunderstood areas across multiple syllabuses, and I mean all of them, from 0625, 0651, 0652, 5054, all the way up to the advanced 97002 papers. We are talking about the fundamental quantum equation HF equals E1 minus E2. Today, we are entirely focused on formation, tactics, and execution. We're going to look at the exam paper as a strict defense that we need to outplay. We will break through those question barriers using the precise, strategic framework that top-tier students use to secure maximum marks. So, get your notebooks ready. We are going direct to the source, the principal examiner reports, to build your ultimate tactical playbook.
Now, what you're seeing here brilliantly illustrates the ultimate trap that so many hard-working students fall into. Let's look at Alex on the left. Alex is like a player who wildly kicks the ball in every single direction, hoping something, anything, goes in the net. The answer is just overflowing with raw physics facts. We've got mentions of Bohr models, random constants thrown in, a complete brain dump. But there is absolutely no clear structure, there's no analysis, it's just a massive wall of text. The examiner literally has to go hunting for the actual answer. Conversely, on the right, we have Sam. Sam makes a rush sprint toward the goal, writing a super short answer that completely misses the specific command words in the prompt. Sam didn't decode the defense. And here is the harsh truth. The examiner doesn't care how much raw physics you know if you don't play the formation correctly. Both of these approaches lead straight to 0 marks.
Here is our exact blueprint for today to shift your approach from passive memorization to strategic exam execution. First, we tackle the challenge. Second, the method mark strategy. Third, we cover examiner warnings. Fourth, an interactive workshop. And finally, the success blueprint. Let's get moving.
Section 1. The Challenge. Mastering Core Principles.
So, we really need to understand why interpreting complex data in atomic line spectra is so notoriously misunderstood year after year. Listen, it isn't just about memorizing a formula. It is about the theoretical architecture behind it. The equation HF equals E1 minus E2 is your primary offensive tactic. Let's break it down. E1 and E2 represent two discrete, highly specific atomic energy levels. Imagine an electron transitioning from a higher energy level dropping down to a lower one. It's like stepping down a very specific staircase. That energy difference doesn't just vanish into thin air, right? It is conserved and it is emitted as a single photon. The energy of that emitted photon is exactly equal to the energy gap calculated as HF, where H is Planck's constant and F is the frequency of the radiation. You have to explain this causal relationship clearly. The discrete energy gap directly dictates the specific frequency, which in turn creates the distinct spectral line we see on an emission spectrum. Grasping this core principle is absolutely crucial because the syllabus demands that you apply this systematic reasoning to completely unfamiliar contexts.
Now, what's really interesting about this insight is the explicit examiner proof that combining topics is your golden ticket to the top grades. The theoretical architecture of this topic rests on precise definitions, but more importantly, integration with other syllabus areas. How does this quantum concept connect to waves? How does frequency relate to wavelength using the standard wave equation? Or, how does this tie into electric fields if we are accelerating electrons to cause these atomic excitations in the first place? When you show the examiner that you understand the entire physics ecosystem, you completely bypass the standard defense and score maximum points. Top-performing students don't just see isolated topics, they exhibit a connected conceptual understanding.
Section 2. Method Mark Strategy. The Insider System. But before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Okay, let's look at how this builds a foolproof, standardized sequence where you physically earn method marks just for showing the correct procedural steps. This is where we apply the Peel framework. Point, evidence, explanation, link directly into your physics answers. Step 1. Deconstruct the question. You have to decode the command words. Does the defense want you to state, describe, explain, or determine? Each word requires a totally different tactic. Step 2. Extract relevant data from the complex text or tables provided. Find your evidence. Step 3. Select your analytical framework. This is your explanation phase. Set up your HF equals E1 minus E2 calculation. Step 4. Execute with clear, legible notation. Let the examiner follow your logic step by step. Don't make them guess what you're doing. And Step 5. Present correct terminology to link it all back to the initial point.
Executing this specific sequence practically forces the examiner to give you marks because you align perfectly with their standardized marking sequence. It's a game changer.
You literally cannot skip the basics here. Defining your terms sets the logical foundation for your entire analytical response. Principal examiner reports reveal that candidates consistently confuse key terminology and lose incredibly easy marks. If you're going to use H and F in a written paragraph explaining the concept, you must explicitly state that H is Planck's constant and F is the frequency of the emitted photon. Never assume the examiner will just give you the benefit of the doubt. They won't. In Cambridge papers, particularly the rigorous 9702 AS and A level, presentation of information follows strict conventions. Proper headings, correct terminology, appropriate formats, and clear annotation are not optional. They are the fundamental rules of the game.
Section 3. Examiner Warnings. The Danger Zone. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's explore how to protect those hard-earned marks. These are the specific, repeated errors that principal examiners flag year after year when students tackle atomic energy spectra. Let's analyze these defensively. Mistake 1. Confusing cause and effect. This is huge. Students often write that the emission of the photon causes the electron to drop. No way! That is backwards. The electron transitions to a lower discrete energy level first, and the result of that energy loss is the emission of a photon. Mistake 2. Forgetting presentation conventions. This means leaving off your units or not showing you're working out clearly. It's like dropping the ball right before the goal line. Mistake 3. Providing generic answers not specific to the context. If the question asks about a specific energy transition in a hydrogen atom yielding ultraviolet light, you cannot just give a generic answer about visible light spectra. You must make your point, provide evidence from the specific question, explain the physics, and link it back to the prompt.
To prevent formatting and contextual errors under extreme pressure, you should absolutely leverage memory hacks to instantly recall the strict conventions required. Look, when the clock is ticking down and you have 60 seconds to finish a massive calculation, panic sets in. We've all been there. That's exactly when you forget your units or skip a crucial step in your working. By creating a mnemonic for your analytical framework like deconstruct, extract, select, execute, present from our earlier steps, you give your brain an automatic roadmap. It stops you from rushing the goal without a plan. You rely on your tactical training to ensure every single procedural box is checked for those method marks.
Section 4. Interactive Workshop. Data Extraction. Okay, let's put this into practice with a high-stakes, interactive data interpretation challenge straight from the Cambridge framework. I'm putting 60 seconds on the clock right now. Scan this data carefully and look for the relationship between the energy gap size and the resulting frequency. Can you spot the core trend? We have 3 theoretical energy transitions here. As the gap between E1 and E2 gets larger, what exactly happens to the value of F? Remember our core principle, HF equals the energy difference. Since H, Planck's constant, is a fixed number, the frequency F must be directly proportional to the energy gap, right? The larger the transition gap the electron falls through, the higher the frequency of the emitted photon. Spotting this trend instantly gives you the analytical framework required to absolutely crush the subsequent questions.
All right, challenge 2. Read between the lines here to figure out why this seemingly accurate physics conclusion is actually bleeding marks. Let's say a student writes, transition A produces a higher frequency photon than transition B because transition A has a larger energy gap. It sounds true, right? It applies the physics perfectly. But if you look at the examiner commentary for higher order assessment objectives, this answer is incomplete. Why? Because the prompt likely asked to compare the 2 spectral lines produced. The student only stated one side of the effect. They didn't analyze both similarities and differences, and they didn't back it up with hard data extracted from the table. It's a weak play.
And this brilliantly illustrates the answer. You must explicitly state the differences and back them up with hard evidence to hit those higher-order assessment objectives. This is where your 30-second speed writing practice comes in. When Cambridge asks for a comparative analysis, you need to follow these 4 rules strictly. Identify similarities and differences. Use comparative connectives like whereas, conversely, or in contrast. Support each claim with evidence, actually quote the frequency numbers from the table, and finally draw a conclusion. A perfect comparative Peel paragraph here would say, transition A produces a photon of frequency X, whereas transition B produces frequency Y. This is because the energy gap for A is larger than B. Therefore, transition A will produce a spectral line further toward the blue end of the visible spectrum compared to B. That is exactly the kind of tight, concise paragraph you should be outputting.
Section 5. Success Blueprint. The final system. Let's tie all these strategic threads together into your ultimate exam execution plan. By adopting this deconstruct, solve, evaluate timeline structure, you are guaranteeing that your time management matches the examiner's marking criteria. This is our time management matrix for a standard 10-mark multi-part question. At 0 minutes, you are strictly identifying key elements and decoding the command words. No calculating yet, just breathing and planning. By minute 3, you've selected your framework, like HF equals E1 minus E2, broken the problem into logical steps, and you are solving systematically, showing all you're working for those beautiful method marks. At minute 7, you stop and check for reasonableness. Does your calculated frequency match the expected order of magnitude for visible light? If you got a negative frequency, you know you swapped E1 and E2. Catch it now. By minute 10, you are making your justified recommendations or conclusions perfectly formatted.
Reaching 100% of your mark potential requires strict adherence to our 3 golden rules. 1. Command word decoding. 2. Peel framework application for all descriptive answers. And 3. The time management matrix we just discussed. Proper headings, correct terminology, and clear annotations every single time. If you combine these tactics with a solid theoretical grasp of atomic energy levels, you become an unstoppable force in the exam hall. You are no longer just a student hoping the right questions come up. You are a strategist executing a proven playbook.
Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. When you understand how the examiner thinks, the entire game changes. You stop losing points on formatting and start capitalizing on every cross-topic connection available. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Is it the math, the descriptive paragraphs, or time management? Our team responds to every comment. Like and share this video with a study partner. Keep your notes organized, practice defining your terms, and remember, mastering the complex physics behind HF equals E1 minus E2 is only half the battle. Executing the strategy is what actually wins the exam. Ace the Exams. Your Cambridge success starts here.